On the bench we have a Royce 1-640. I've installed a channel only mode DDS, and it allows for up to channel 50 is the highest. The power drops off drastically with this particular radio above 50. So I've set it to channel 50 and down to -10. And it does pretty good. I've got up here in the corner. Let me move in here a little bit. Move in on the display. You can see the F there. That means for fast. You press the button for S and F. Well, the S is for slow, which moves every half channel. The 5 is standard channel, 0 is halfway in between. And then fast moves every channel. Then you see the A up there in the corner. That's because I'm on the old RC channel. And you come down here to 3, you can see there's 3A. That's a half channel. Then 11, the half channel. 15, the half channel. And 19, the old RC channels. So it worked really well. I'll show a little bit more here about how I did it. Well, first thing we had to figure out is what are on this very first crystal is what we need to run on this oscillator. Well, they used a 7.779.66 or 166 crystal on that oscillator to achieve the frequency, but the frequency that they use is the third harmonic of this crystal to reach their 23.33. So that threw me a loop of what they were doing to begin with, and then I figured out that they were using the harmonic of 23.33. Okay, that gives us our start frequency. That gives us the frequency we need to feed at this oscillator to get all the channels to line up properly. And then we used these two sideband oscillators here with these crystals to get our upper and lower sideband frequencies. That's our mix. That's our mixer crystal, which is 14 megahertz. Now those crystals are at 14 megahertz. The problem that I ran into with those is on this, the clarifier no longer worked once I fed at this point for our 23 megahertz. So I had to isolate this crystal and this crystal, isolate them, put a replace these fixed capacitors with varactors. This one and this one with a varactor. Bypass the channel selector. Well, I was getting rid of the channel selector anyway. So bypass the channel selector with this crystal and this crystal to these oscillators. But once I put in the varactor here and here, then I could come off this point here with this, from this coil to a pair of coils, because you put coil to the varactor right here at this point, and so that I could have variation in frequency on these two crystals, so I could have my upper and lower sideband. Meant I had to align them, so I left the varicap in there so that I could adjust the frequency on these two crystals. That allowed me to line up the crystals so that our clarifier was centered, which it worked out quite well. Well, down here on the bottom on the crystal board, you can see these two red wires. They're your upper and lower sideband crystals bypassing the channel selector that comes from here up to here on the lower sideband. Now see these two green coils? These are connected to the varactors down here. There's two little diodes down there, which are the varactors that I pulled out that fixed resistor or fixed capacitor and put in these varactors. Then this brown wire here comes from the clarifier, which feeds to the center of these two coils here, which sends a voltage to the varactors to change their capacitance. These two coils are to stop the frequency from backing up from each crystal and interfering with each other. Then this wire over here comes from the RF generator. This is my 23.33 feed is right up here, which is connecting to right directly to the oscillator. Well, then next I had to pull the face off. That was not easy because you got a nut up here, a nut here, and one down here, way back in there. Let's see if I can get to it. There we go. You can see that nut down by the potentiometer. Well, I had to grind a socket in order to get into it. The hardest one was over here in this corner. Down here is right beside this potentiometer here, packed right down in underneath there. That was a hard one to get out of there, but I had to get those out in order to get the face off to be able to take and get the channel selector out of it. To get the channel selector out, see these studs right here? Those studs were actually connected to the front plate, and then the channel selector had a plate that mounted to these studs. There's 4 of them there. I pulled 4 screws out, and then be able to take the channel selector out, but you still can't get the channel selector out till you get the face off of it and pull the channel disc. Once those are out, then you take the plate that was here, mount it to the front. Mount it right flush to the front. That gives you a place to mount the encoder. Right down in here is your encoder. That'll mount to that plate once you get it bolted to the front. There's just enough room between this plate and the front to put a display in there. I put a little .96 display in that location, and that shows right through the window, the channel window. Then I came off my encoder. I'm using a hub on this one, but you don't need to use the hub once I get the new RF generator in. The new RF generator is only a single port, not a 3-port. So I'll be able to come right off the encoder, plug right into the RF generator, come off the RF generator right into the Arduino. That's a little tiny Arduino. And it works out good because that makes it nice and small. The RF generator will be mounted to this plate, and the Arduino will be mounted to this plate. And also the 12 to 3.3 volt inverter will be mounted to this plate. That plate works out really well. I'll just take and make a plastic housing and connect it here, connect those units to that plastic housing, separating it from the plate. And then I'll take and come right off that RF generator, that single port, right down to this point right here where I've got the RF generator right now. But that's all there is to hooking up the DDS, the channel only mode DDS, in a Royce 1-640, and it's pretty neat. But we'll get that finished, put back together, get it all hooked up, and show you again what it is when it's all done. Now we'll get into the hard part. What I've showed you so far is the easy part. Okay, here's the Arduino IDE. Okay, first thing, of course, we've got our includes. The SPI include wire, our Adafruit GFX library, and our Adafruit SSD 1306, and our Adafruit Seesaw, and the Seesaw Pixel, and the SI 5351H. Okay, the wire library we need for our I2C. The GFX is for our graphics, our letters, and so on. And then the 1306 is our display. The Seesaw is our encoder, the Adafruit encoder. The NeoPixel, now that's for the pixel on the encoder, which we're not using. Then the SI5351 is the RF module. Then we go into our screen size, which is 128 by 32. The 1306 no splash is supposed to get rid of the Adafruit logo when you first fire it up. It doesn't work. It's still there. I've got to figure out how to get rid of that. Then the OLED reset to -1. And then our screen address, which is X03C. That's for our display. Then we call the display the Adafruit 1306. We activate it. And then, of course, the Pixel, which we're not using. Okay, the 0x36 is the address of our encoder. The NeoPixel we're not using. Okay, starting here, DF, default frequency. That's the frequency we need for our crystal replacement, which is 23.3306. I had to adjust that. This particular one I had to put in 06. Then our offset frequency of 3.6344. That was to get the proper offset so that the frequency comes out to 26965, which is for channel 1, which is what we're starting with, is channel 1. Okay, then DS, that's our count default step, which is per 10 kilohertz, one channel at a time. UFL for upper frequency limit. This is where we set the frequency, the max frequency we want to use on whatever particular radio you're using. And then LFL is our lower frequency limit, which is how low do you want it to go. You can expand these by quite a bit, but I've got another program I'm using that also displays the frequency and the channel and what steps you're going, whether you're going 100 hertz or 1 kilohertz or 5 kilohertz or 10 kilohertz or 100 kilohertz or 1 megahertz. But that's for the multi-channel with a frequency display. This one here I'm not using the frequency display. The encoder position setting, rather it finds the encoder position, new position, that tells it whether you're, or gives it the defaults for up and down. The frequency steps, I've got this particular one channel mode, either 5 kilohertz or 10 kilohertz. And I'm using the F and the S as for fast and slow. Slow is 5 kilohertz steps, fast is 10 kilohertz steps. This section I'm calling a string to be able to do the channel 1 through 23 because of the way they set up the 23 channel radios. You have the skips for the old RC channels, and then you got this skip around for channel 23. You got your missing channel in there, and then it goes from 22 to 23, which is actually 27,225 for 22. Then 23 is 27.255. So I had to set it up so that it reads the proper channel for whatever frequency you're on. And then I set my, or called for my channel mode count, that's where I'm storing my frequency. And then the channel count and string of channel count A, but yeah, that'll go into further down. Here I'm going into frequency generator, which is my SI5351. I'm calling that, I'm activating it basically right there. Now there's my calibration factor for this unit. You got to do a calibration factor or your frequency won't be correct. Then I'm calling a bunch of different stuff. I'm calling different things as I go down through here. Rather they're a number, which is the int, or rather it's a string. Okay, and then under setup, I'm initializing my display. Okay, then a display, clear display. Then I'm going into initializing my encoder down through here. Ooh, I need to get rid of the some of the serial print ends. But okay, now this one. That's for the encoder. Go on down through here. Most of this stuff's all for the encoder, and which you'll use example to get most of your programming for the encoder. Okay, then the frequency generator, and then if it finds the 5351. It tells it either found it or didn't find it. So if you wind up your display is not quite right, or it locks up, check the serial monitor. Hook a computer up to it. Go into the Arduino IDE. Look at the serial monitor when you fire it up. It'll tell you whether you can't find something. Okay, then this is where I set my calibration factor. Here I set frequency to default frequency and to clock 0, which is the first port. And then the updated. And then in my loop, I'm just calling rotary. Well, that's down at this void rotary. That's what I'm calling here. Okay, at this point, I'm reading my switch. I have some stuff in here for doing my counts on my switch. Then I got my switch here, which is whether it's 0 or 1. Tells it the push button. What is that in position? Is it in position 1 or position 0? Okay, then the encoder. This is where it's calling for the encoder. Then I'm doing my count equals count plus 1 times my step, which is, go back up here, my step is either the 5 kilohertz or 10 kilohertz. That's my step. And let's go on here. Yep, step, yes. This is whether it's plus or minus on the new position. And then we come on down in here whether it's whether it changed or not. If it changed, then it sets the frequency on the clock 0 to FR, which is my frequency. The FR equals FR plus count. Whatever the count is, whether it's 5,000 or 10,000, then it'll add it to the FR, which changes the frequency here. Okay, then it takes the count back to 0. Then I'm calling my display OLED. That's this void loop, or this void OLED. It's calling this routine, which is where I'm showing on my display different things. But first I had to take the FR, ow cat, divide it by 100 so I could get rid of the excess zeros off the back, and then turn it into a string. I had to turn it into a string in order to be able to divide it up into 3 different sections. On my one that has the frequency display is right here. My first 3 numbers, second 3 numbers, last 3 numbers, so I could add a point, a dot in there so that it divided it up. Then here I'm displaying DS. Forget what DS was. Then I came down here to channel mode count -4, which is part of the number, the channel number. And then here, if the channel count is less than 27 but greater than -1, it uses that chart that I have there from 1 through 25. It uses that to display which channel you're on, because I'm still on the proper frequency, but with it skipping around and skipping channels and so on, I needed a way to display the 1 through 25. And then of course this is the same thing. To here I'm displaying whether I'm on the old RC channel with the A or whether I'm on the regular channel. And then I come down here. This is to skip around there between channel 22 and channel 26. These 3 here in order to show the proper channel. Then down here, channel mode count is anything above, actually that's anything below channel 1, shows the minus channel. Anything above, if it's let's see, where is that? Let's see here, if count is greater than 29, then it reads the first 2 digits of the center 3 frequencies to display anything from 26 through 50. Then down here is anything below channel 1. It displays the channel count -1, -2, -3, up to -10, because that's where I've got my limit set. And then here I'm using this to display the half channel, these either 0 or 5. I'm reading the middle 3 numbers. That's what the MT and S is, middle 3 numbers, and then the substring of that, because it's a text file, or it's a text, or a string, not a number. So that's what I'm using to display whether it's a 0 or a 5, and then update this display. Well, that's that's basically the Arduino code for the channel mode only. Okay, that was a basic rundown of how I did the channel mode only on this Royce 1-640. If you have any questions, just go ahead and post and I'll try to answer them. This has been quite a little project. I've got a little bit more to go, but not much. Radio I've already pretty much gone over, and I recapped the radio and aligned it, and it works really well. But it doesn't spread out very far, so I had to limit it to channel 50 and limit it to -10. That really sucked. The radio doesn't spread that far. Of course, it's an old 23 channel. So please like and subscribe, and we'll catch you in the next one.